Welcome everyone, and today's webinar is called Do Developers, there's bad quality. Do developers write bad code on purpose? And the answer is, of course, not. And so why do we have so many bugs? And we work with a lot of clients these days on their entire software quality process. And what we find is that a lot of the problems start in the beginning at requirements. And so one of our largest focuses now these days in working with companies on their software quality processes is making their requirements better and helping them in that aspect so that their entire software development improves, and not only in speed, but also mostly in quality as well. So we're fortunate enough to have Critical Logic with us today. Critical Logic, we ran into a year or so ago, that have a great tool that helps companies to put together their requirements in a visual way. And so I thought I would have a webinar with in cooperation with Critical Logic so they could show you some of their product features that go with some of the problems that we run into with requirements and helping our clients to solve those problems. So all right, so my name is Phil Liu, and I'm with XPOsoft. I'm the CEO and founder of XPOsoft. We've been in business since 2006. And we work with companies and providing services in software QA consulting and working with companies in their processes, but also hands-on testing work. We have offices in San Francisco and in Beijing. And that's our shameless plug about XPOsoft. As I mentioned, I've got Bob Johnston here from Critical Logic. I'll let Bob talk about Critical Logic as soon as we introduce Bob. But first, a few little housekeeping rules. All of the attendees have been muted, but you feel free to ask questions in the chat panel. We'll be answering them throughout the webinar as we go along, or if we don't get to them, we'll answer them at the end. But in any case, everyone will receive the recording for the webinar. And if you want to do some tweeting, feel free to do that. There's the hashtags there. And so let's move on. Again, my name is Phil Liu. Been involved in software quality for a long time, and actually did my PhD in software quality measurement. So I've been around in software development for forever. I don't want to talk about how old I am though, but I do, on the side, I do like to travel. I think I've been to over 70 countries, and cycling is my passion, which is why I got my XPO cycling gear on, just in case somebody wants to go out for a ride. So Bob, why don't you introduce yourself and talk a little bit about Critical Logic and how you got here today.
Yeah, thanks, Phil. I'm going to start calling you Dr. Liu. I didn't realize that was appropriate. Yes, I'm Bob Johnston. I'm the CEO and founder of Critical Logic. We also were founded in 2006, so we have a very parallel history to XPOsoft. And our company, we primarily do consulting work, very similar to what Phil does. We focus a little more on business analysis, but we always try to bring quality improvement to our engagements. But we're kind of a dual company because we also have a software product, a technology we'll be looking at a little bit here today. It helps us a lot with our work in terms of creating unambiguous, clear requirements, and that leads to much better development work, and especially in our case, much better testing work, trying to improve the whole quality of software through improved requirements and integration of quality from requirements through design, through development, and right into testing. So integrated software testing across the SLA, that's kind of my message here. I am in Salt Lake City, Utah, in the United States, and although my roots are also in San Francisco, our company is a California corporation, but We are scattered around. We are very much a virtual company, do a lot of work in Pacific Northwest, but all over the United States, and we do have some global customers as well. Being here in Utah, I'm very much an avid skier and hiker. We spend a lot of time in the mountains, my wife and I, family, hiking and skiing. Doesn't matter what the weather or season is. That's very much a passion for me. And I'm also very hooked on physics. I'm anything to do with physics, whether it's astrophysics and the new James Webb telescope and all that stuff. I'm a sucker for those headlines. And I also love, particle physics, which I also is a passion of mine. So I'm not a doctor, but I am kind of an amateur scientist. So Phil, that's me.
Okay, I'm curious, you say SLA, is that service level agreement?
Software, no.
Okay,
That's the wrong, software development, the whole software development lifecycle.
okay.
Software, SDLC, I left the D out there, I'm afraid,
Oh, I forgot the D.
SDLC.
Oh, okay, because
Yeah,
it's curious because, we have a lot of clients that have software that's developed by others, right? And so they need modifications to the software or getting software developed. And so there is an SLA, and it's interesting to be able to tie an SLA to software quality. So that's another issue that we're dealing with some of our clients.
well, that's interesting. Maybe we'll talk about this a little bit later, but our primary focus of consulting work is implementing commercial systems. So our focus is on developing interfaces and data transformations for businesses that have bought other commercial software. So in that sense, we're testing it. We're in an environment where there's off-the-shelf software plus a bunch of customization. So yeah, so SLA is an important thing because we try to hold software vendors' feet to the fire. Yes.
Right. One more thing, Bob. I noticed you have a nice critical logic jacket on in your profile picture. So when I see you, I'd like to trade. I'll give you an XPO Soft jersey, and you can give me a jacket. Is that all right?
It's a deal.
Okay.
It's a deal.
All right. Well, let's dig right into it here, in terms of developers writing bad code, and of course they don't. And so some of the things we'll cover today is, if they don't write bad code on purpose, what happens? Why do we have defects if developers don't write bad code on purpose? And a lot of it, we'll dig into some of the root causes of that, which, as you can probably guess, have to do with requirements. And then talk about making requirements testable, and then dig into how IQM Studio enables people to work with requirements and see them in a visual way, and then transform requirements downstream into tests as well as automation code.
Yep.
So let's dig into it here. I think, as there's lots of studies that show that requirements are a huge source of defects, and how expensive it is to fix defects later on in the development cycle versus fixing them in the requirements. But the thing is that, a lot of development shops, they still don't pay a lot of attention to requirements, but the root cause of defects is often not in coding. And there's been lots of studies that show this. Unfortunately, there's still just not enough attention paid to requirements. And, requirements can be really complex. Maybe, Bob, do you have any, it says common wisdom. Bob, you look like you have a lot of wisdom in that area. Maybe you could share some light on that.
Yeah, a little bit every year. So I have a lot of wisdom. Yeah. So we talk about requirements a lot. And, in today's world, requirements is almost a dirty word. It doesn't really have much meaning, especially if you're in an agile environment. Requirements are kind of shunned, or they're just not defined very well. But if you look at my little drawing here, really requirements is, the needs. What are the business needs? What's the intended functionality or behavior of the application? And in some ways you can think about it's the instructions to the developer team, right? What should the developer team do to build this software? And there's a lot of parts to it. It's very complex. But you see, there's user stories, use cases, all the things we're familiar with that we think of requirements. But there's also a lot of other stuff that goes into defining what to actually build, standards, UX design, looking at the old system. Much of requirements, even today, we call ourselves modern developers, but still today, we depend so much on wetware, knowledge of individuals, SME knowledge, and so on. And there's lots of other, every project has a whole wide category. And this information that we call requirements is not very well organized. It's not very well integrated. There's all kinds of challenges to take what's in that requirements cloud and get the development work done. And what's really causes a lot of problems is that there's an interpretation going on in that analysis of what's in the requirements cloud. And that interpretation is done by developers independently of testers in most cases. So the judgments, the analysis, the decisions, the conclusions reached by those two groups is often not synchronized very well. So they have a different view of what we call the requirements because there's not a really good, strong process to integrate and create a single view of what the requirements really are, so the development and test can both be on the same page of getting the work done, right? So it's complex is my message here. And much of the problem is not what the developers or the testers do, but what they analyze and what they have available to them in the complex cloud requirements. So yeah, so that's the point here. It's complex and people read documents in different ways or read documents and see different conclusions.
Yeah, I think what we've run into, like you said, is complex. So you have this complex thing going in on the left-hand side of the cloud. And then on the right-hand side, what we found is that a lot of people get into implementation details before the actual requirement is really well known. And so talking about buttons and so forth, that's actually the requirement, but it really is not the actual requirement in terms of from a business or end user point of view, what they really want to accomplish.
Yeah, we call that, Phil, in our practice, we call that solution independent requirements, right? That the requirement is what it should do functionally, how it does it. If you jump to how it's supposed to work right away, you've already started making some decisions that may not be accurate when you finally look at the actual requirement and completion.
Right. Okay. So let's look at some of the reasons for these complex requirements or poor requirements. A lot of times people assume things, right? And so one developer may assume that a requirement means a certain thing, but the business analyst or the stakeholder meant something different. And so the requirements versus design issue is what we just talked about. Ambiguity is another big issue. And there are actually ways that you can, people think, well, how do I solve ambiguity? But there's a lot of tools and ways that you can solve ambiguity. And here's some examples on the right that from the complexity and ambiguity of poor requirements, right? So we've run in, these are just some examples I talked about on the right. On the fourth bullet point, you can see that that's already going down into the implementation details, right? And so those kinds of things, when you dig down into implementation versus looking at the requirement, and you may see words like expected, confirmed, correct, but those things are not really well defined. So there's a lot of ways that you can even just scan your requirement just for certain words. And if you clarify those words, that will actually, be part of your 80-20 approach in cleaning up your requirements.
Right.
Maybe you have some additional knowledge that you can share on poor requirements and maybe, expound on some of these.
Yeah, unfortunately, I actually have some hope that AI is going to help with this pretty soon, is looking for ambiguity. But because much of our requirements that we deal with are written documents, right? Human language. So we look, for instance, another example I would bring here is if you see a user story that says, if the user does this, then this should happen.
Hmm.
What's always missing when you see a written narrative that says if then, what's usually missing in ambiguous is the else part, right? If then this should happen. Well, what if that doesn't happen? What else should happen, right? If I enter a valid user ID, I should get logged in. Okay, well, what happens if I don't enter a valid user ID? So then what happens, right? So oftentimes that structure we look for in languages, if statements, but we look for the then and the else. And if we don't see an else or a very clear then, we will raise a question, or we'll just tag it as saying, hey, there's a little ambiguity here. Let's see if we can clarify this. So these examples we have on the screen are also kind of target words we find when we read things. So yeah.
Well, that's interesting. When you mentioned the if then else, it really makes a lot more sense, because as a coder, you think of the select statement and you think of an if then else, and there could
Right.
be, 6, 7 levels of if then else.
Right. But
Yeah,
nested, yeah, it can get complicated and beyond human ability to really see it. I mean, when you read a sentence like that, your brain doesn't think, well, wait, what happened? You don't think in terms of if then else or a
sure.
select statement or, ambiguity at all. But that's why there's a skill, and we need some tools to help us figure out if we're looking at ambiguous requirements or not.
Wow. Okay, well, let's talk a little bit about the other side in terms of ways to make requirements good, testable. We've talked about the ambiguity and incompleteness of requirements, making requirements understood, and that really leads to testable requirements, right? And so testable requirements, we want to make sure that, as Bob just talked about it, in terms of the if then else, having all of the possible inputs and outputs predictable and being able to know what those are. But one of the things I'd like to mention here is the stakeholder issue that, what we find with a lot of our clients that we work with is that multiple stakeholders are involved and they have such different viewpoints on what should happen and what should not happen. And then when you get to the point of doing acceptance testing, and then the stakeholder says, oh, that's not what the way it should work. So how can we get around that and avoid that? Maybe Bob, you've had some experience with that as well.
Yeah, very much. I mean, this is what we call that as consensus, right? If you don't have a consensus or a false consensus, and that's really what you're talking about, everybody thinks they know, the stakeholders, the business, the developers, the testers, they all go, yeah, I'm good. I know what I'm supposed to do. But do they have a consensus of what they're supposed to do? Are they in agreement? Do they see apples or do they see oranges? And this leads to all kinds of problems, right? So one of the things, unless you have really clear requirements and they are, agreed upon, that they are valid, and that all the different stakeholders can read and see the same thing and raise their hand to say, yeah, that's what we want to do, or wait, no, that isn't what we want to do. If you don't have that discussion and that again, consensus of what we should be doing and a mechanism to see, yes, that's what we want to do, and point at something, then you're going to have problems, right? You're going to have technical debt. You're going to have conflict of and inconsistent rules to how the software should behave. So yeah, these things here validated by stakeholders is really important to get not just clear requirements, but agreed upon requirements.
Yeah, I think the big problem here is something that came up on my desk today is in terms of reading. One of my project managers was saying, I sent the client this emails and blah, blah, blah. And I said, well, what if they don't read that? And so a lot of people just don't read, right? So that's why one of the things that I thought about when I saw the critical logic tool was that the visualness of requirements, and therefore enabling people to really understand it at a glance without reading through some long user story and say, oh yeah, this is okay, and this going like this, but being able to look at it quickly and be able to see if there's a problem. I think that's one of the powers of,
Yep.
that's one of the things about humans is being able to see things visually and conceptually. And I think that's really important.
Yeah, visual is good. Yep.
Yeah. Okay, so, when we get to having good requirements, part of the one of the critical elements of a good user story is acceptance criteria. And again, we work with our clients on acceptance criteria, and a lot of them, I wouldn't say bad acceptance, maybe bad is the wrong word, but incomplete acceptance criteria or unclear acceptance criteria. If you look at this example here, user can create a child requirement from a current requirement successfully. I mean, obviously, that could mean different things to different people, right? So what does success mean? And what does child mean, right? So a lot of these things, from one person's point of view, maybe a coder, they may think one thing and then somebody else may think another thing. And so I think, I won't read through these exact ways of correcting that statement, but I think it's pretty obvious that when you have a requirement and you have a big broad statement like that under the ungood or the non-good acceptance criteria, we want to be able to clarify those things. And as Bob said, the if then else, thinking about that is also very, very important when determining a good acceptance criteria.
Right. Yep.
Let's see, let's go on here. So, we have, as I mentioned before, one of the things about the critical logics tool, IQM Studio, that I really liked was the visualness of it, and being able to visualize some cause and effect, basically input and output. This happens, and then it goes into this magic cloud and outcomes in your software. This is outcomes the result, whether it be a report or a button that you push or a choice that you make in a choosing between different options. And being able to easily visualize that makes things easier for different stakeholders with different points of view to agree and get consensus.
Yep. Yep.
Bob?
Yeah, that's right. Bill, so I think, what we're starting to talk about here now, I think we've defined the problem pretty well, right? It's not easy to distill and synthesize all these various sources of requirements into a common understanding of what should really happen. So we, many, many years ago, started realizing that was something that required some technology to do. So we'll talk more about the technology here, but the basic idea is to take that cloud of complex requirements and be able to pull pieces of that into what we call a cause-effect diagram, as Bill said. And the diagram there, we'll look at some real examples. But what that diagram represents is the logical rules of the various inputs and outputs that are encountered in the requirements, right? So if I do these things, this should happen. If I don't do them, something else should happen. You can't get to this state of the system unless these things are true, and so on. So once we build this visual diagram, you see a little picture of here, we then can have something that is unambiguous. And if you are a tester or a developer or a stakeholder, you can look at that and there's no question about where that line goes, what's required to get to a certain state or condition, what the various combinations of inputs are. That is all the diagram is capable of defining all of those relationships. And again, we'll look at that a little bit more, but the idea is we're trying to synthesize the important parts of the requirement cloud into a common view of the functional rules of the application, okay? So, and then that common view can be agreed upon, reach a consensus of the stakeholders and provided to the testers. And if you have an enlightened development group, they will also look at that and say, yeah, that's what I'm supposed to be. Those are the tests I'm going to have to pass, so I better pay attention to that. So yeah, this is kind of an introduction to the idea of synthesizing clarity out of the cloud of requirements.
Right. Well, I'm looking forward to seeing more details of that center diagram there.
Yeah, well, we'll get there. Couple
Okay.
more slides.
All right. Oh, there's a little, it's a little bit bigger, so we can see a little bit more now.
Yeah, yeah,
So,
yeah.
one of the powerful things about that we've looked at with your tool is the ability to take those requirements and then, if you can generate clear and unambiguous requirements that are also complete, then it also generally, it naturally leads to test cases, which also have all the paths defined. So that's one of the great things that we thought of when we saw your tool, Bob, in terms of
Yeah.
generating test cases with acceptance criteria, and also integrating with different tools to generate test automation scripts. So I think it's
Yep.
one of the great things about IQM Studio. So I'm really looking forward to seeing it in action as well.
Yeah, so that's right, Phil. And I won't spend much time on this slide, but the one important thing I want to point out here is that the process of creating these diagrams requires certain formality that I understand what the requirements are, right? So I mentioned before the if then else statement. When we build one of these diagrams, the logic diagram you see there, that forces us to ask and answer questions back to the requirement source, right? So we raise an ambiguity. If we can't complete the diagram because it doesn't tell us in a user story what's supposed to happen, then we will say, hey, what's supposed to happen here? So the mere act of creating this logic diagram creates this feedback loop that improves the requirements naturally. Because we're going to say, if you build a model, we have to have enough information to build the model. That improves the requirements kind of as a side benefit of building the model. But an important one, because if the requirements are incomplete or ambiguous, we won't be able to develop the model and we won't be able to test right. And we can prove it. Hey, if you don't have the right requirements, we can't test it. And that's the whole point here, is that the creation of the diagram works both directions, upstream, improving requirements, downstream to create very useful artifacts of tests and scripts.
So it actually, I guess you could say, kind of forces you to write good requirements. Maybe that would be a good way of putting it.
Yeah, we talk about validating the requirements. So if we take the requirements and they don't make sense to us or they're missing pieces, we will say, hey, we can't validate these are correct. We have some questions, and the questions get answered, and then the requirements get validated.
Yeah, that's probably validate is a kind word, just forcing people to write.
Yes, yeah, we try to not piss people off.
Yeah. Okay. So, one of the final things before you dig into the actual demonstration is that reporting is critical, right? Whether you're doing automation or test results or anything. And so I think it's important to realize and think about, what are we going to do with all these requirements? What are we going to do with our tests? And it's always a constant problem for QA to show the value of what they're providing. So when we get to the tool, Bob, I want to make sure that we dig into the results that come out of what we're doing so that we can show what value we're adding, whether it be tracking defects or tracking the completeness of requirements or and things like that. So I'm sure I think one of the critical things is the coverage, right? So that's one of the powerful things about the tool is that ensuring that coverage is complete based on the requirements, right? So if the requirements are complete and the tests are complete, then the coverage is going to be good. So let's let's dig right into that there. So I see you have quite a few. We put in quite a few screenshots from the tool, but I think these are probably a little too hard to see for folks. Why don't we just dig right?
I'll show you these in real time when we get there, but there's a variety of reports and traceability, as you were saying.
Let's dig right in here. And one of the last things that which I just talked to a minute ago was the generation of executable code. And I noticed you've got just about everything in the world on the right hand side there. That's pretty good. That's fantastic. Python, we do a lot of work in Python and Java as well as Selenium. This is fantastic. Most of our clients work with one of those platforms on the right hand side, so that's fantastic.
Yeah, and our whole idea is that our framework is totally configurable to generate executable code of any kind. So, you know, our framework is very, very flexible in terms of the syntax of the code, the structure of the code, and so on. So once we generate that code, one of these tools, the one you're using, or maybe more than one, we'll be able to generate the correct syntax so you can run those tests with that tool. Yeah.
Great. Okay, well, I'll let you take it away here, Bob, and you can,
Okay,
can
I think you need to make me
yep,
presenter somehow,
I think
and
I will stop my share.
okay.
And you are co-host, so you can share away. I'm sure.
Share screen, yep,
There you
okay.
go.
You are sharing, okay. Get rid of that Zoom meeting. Get away. Yes. Okay, so I'll start out. I want to start out by I'm going to do an example. I want to work through a model and the whole process from end to end. I'm going to go pretty quickly. There's a lot of details here that I'll kind of just breeze through because there's a lot of functionality. But I kind of want to set this up this way. I want to set up an example. I can click the right button here. There is I'm going to use this little example here of a testing. Let's say I want to test this sign-on. This is a company called Cool. They sell outdoor clothing and equipment. They're here in Salt Lake City. I'm a big fan of theirs. I'm on their site a lot. But in a really simple case here, I'm going to create a model of the rules for signing in. So on this screen here to sign into my account, there's a sign-in screen. It has things like use your email and password and so on, but it has rules. For instance, if I click sign in without filling any data in, right, it's going to give me an error message that says you must enter a valid email address. But if I do enter an email address, there's another rule, that says if I don't enter my password, it's going to give me another error that says, hey, you got to enter your password. Okay, this is pretty simple. But the complexity of the rules here is a little surprisingly more than you'd think, right? Because you have to do things in the right order. The data has to be valid. You have to put something in that's valid, not blank, and blah, blah, blah. So we're going to analyze that a little bit here. So let me start also that the requirements for that sign-in logic are something like this. I made this up, but you can see here I have a requirement list. Requirement number 1 is sign in, user ID is required, password is required, valid credentials. I also have a requirement that the cool logo is displayed and there's a correct instructions in the right language on the screen, okay? And this would be much longer for a real example, but the idea here is that I have some requirements I want to test, I want to understand, and I want to trace back to these requirements, okay? So that's the setup. They have a little simple application and a set of requirements I'm going to try to test. So I will take that set of requirements as an analyst here, and I'm going to come to my tool. This is called IQM Studio, and we're going to be focusing on modeling and automating. But as Phil was talking to a minute ago, we also want to be able to synchronize things we produce, like test cases, up to a test management system. So if you have a test management system like Azure DevOps or Jira or something like that, we want to make sure that our test cases that we are generating are also known and managed by another tool. We create an integration to that. We also have a tracing capability where we trace everything we're generating in our model back to that set of requirements I showed you. So if you have your requirements in Azure DevOps or some other tool that has requirements, or maybe you just have a spreadsheet of requirements, we want to track what we do back to some external requirements, okay? So high level, let's look at a model, okay? So this is what the UI looks like, okay? We have a drawing template or an area where we can draw in this workspace, and we have details about the drawing over here. What we're looking at is something we call a cause effect model. And the lines between what we call nodes here are logical connections between the nodes, okay? So don't want to get too into the weeds here about this, but let me just walk you through this little example. So here, this example is going to test the sign-in screen for the Cool website, right? So what are the rules to sign into the Cool website? Well, first thing we have to do is log into the Cool website and get to the account screen where I can sign in, right? And then once I get to the sign in screen, I want to be able to click sign in, but first I have to enter the user ID and the password or some combination of valid and invalid user IDs and passwords. So what this is describing is when I set out to test whether the user ID is correct and valid and certified, there's really three choices. If I have a blank user ID, I can leave it blank completely. I can type in a valid ID or an invalid ID. And we're saying, okay, the rules, the requirements are I have to be able to handle those three different situations. So here we're saying, okay, but this is an important part of the logic here. Only one of those things can be true at a time. It's either blank, valid, or invalid, right? And the same structure here for password. It's either blank, valid, or invalid for the user ID entered, right? So let me just jump ahead a little bit. For us to get to the account screen, my account screen, and verify my personal profile information, there's several conditions have to be true. I have to have a valid user ID, and you can see this line right here, this connecting valid to account screen. I also have to have a valid password. So this connector here is connecting to that. And I have to click the sign in button. Actually click it. If I click it and it's valid user ID and password, I get to the account screen and then I can go on to verify my account data, okay? Now, if we look at some of the other conditions possible, what if I leave the user ID blank? Well, it turns out if the user ID is blank and I click sign in, I should get an error message that tells me the user ID is required. You have to enter it, right? And so on. If I enter an invalid user ID and then I leave the password blank, okay, then I'm going to get a different error message. If I enter a valid user ID and then I don't even care about the password, but if I enter invalid password, then it's going to want a valid password here, and that's going to take me up here. So it turns out this through there's some training needed to be able to actually build this, but it's actually pretty straightforward. Okay, when you look at it. Now this is the cause effect model view, and I put this little note down here. This is a case where when I read my requirements, it wasn't really clear what's going to happen if you entered a password, but you left the user ID blank. So I said, hey, it's unclear here to me what's going on. I made an assumption that if you don't enter a user ID, but you do enter a password, that something's supposed to happen, right? A certain message is supposed to appear. But this little note is going to be pushed back from me to the requirements, okay? Now, let me just stop there and say, I've built this little drawing. Now, here's what the tool actually does. When I click a generate button here, what's going to happen is it's going to analyze all the various paths through this logic diagram with various combinations of valid and invalid blank inputs and all the things you can do. And it's going to tell me there are 18 different paths through this simple model. But I can test all 18 paths in 5 test cases. This is what it's saying right here, okay? And I can immediately go look at those test cases. So here I'm going off to my report center, and our simple basic test case view is right here. I'm going to just open this up, and this is showing me the test cases that I need to test all of those rules, right? So test number 1 is that I go through a valid user ID, valid password, click sign in. I should get to the sign in screen, and then I should verify my data. Test 2 is enter invalid user ID. Test 3 is enter valid ID, but invalid password, and so on. So this mathematically defines all the different combinations of input that need to be tested to give us full coverage of all those business rules for that screen, okay? And there's some other views here. I won't spend a lot of time, but like, some people like to use a BDD format, right? This is the same test cases, but here they are in BDD format. Given this, that, when that happens, then this happened, then verify. These are given when then structures that represent the same test cases that we generated when we push that button. Okay, so and so on. One of the other, there's other report formats and so on you may find useful, but one of the important things here is the requirement traceability matrix. So I'm going to look here, and this actually creates a spreadsheet. Go ahead and create that spreadsheet. And that spreadsheet then shows me all the requirements that I have that I'm tracking, okay, and all of the ones that have test cases that are testing that, okay. Oh, I'm sorry, I needed to regenerate. Generate reports. Okay, where to go? Sorry. Spend time on this. Where'd it go? Where'd it go? It's a demo, right? That always happens. Shoot. I must have. I think my Excel crashed on me. There we go. Go away. Okay, so again, it's going to tell me what test case. This is test by test 4. This is test 5. This requirement is tested by test 2 and test 3. And these two requirements are not tested at all. Okay, so this report is telling me the model is including functionality for these 3 requirements and exactly where those requirements are tested. And there's also other requirements that are not included in the model that are not tested. Okay, so this information is traceability matrix is very important input information. Okay, now let me there's a lot of detail here. Let me just go one step into this. Let's look at this this node here, verify profile details, or so this, when I edit this node, there's some information here about what happens when this node appears in a test case. Okay, and there are some requirements that I can say, hey, when this node is in a test, it's testing requirement number 1. So I can assign requirement 1 to that node, and wherever that node shows up in the test, I know that node and that test is executing against that requirement. Okay? And I also, the other part, I'll just jump ahead a little bit here. The other part that's in this individual node is to automate. This is telling me connect a little bit of automation to this node. So when this node appears in the test case, I know how to generate the automation code for that particular step in that test. Okay. So let me jump ahead on that too. I know I'm going faster and there's a lot to see, but let me jump over to the automate side just to watching our time here. So in Studio, I'm then going to navigate over to the automate side. Okay. And in the automate side, we have a little different view of what we have stored. In this case, the model I'm working on is called sign in 2. And what we see here are the same 5 test cases that were generated by the model. If I open one of these test cases, now we're looking at what we call a keyword view of the same test. So the same test, you can read it here, launch the cool app, enter a valid user ID, enter a valid password, click sign in, verify the profile screen is displayed, and verify the profile screen has the correct data on it. Okay, those are the basic steps of this test case that was created by the model. And we've also, behind the scenes a little bit, told Studio what to do on each one of those steps for automation. So a little different view here. I can click this narrative button and generate this view This is what we call our narrative view, which is an exact mapping of what the automated script is going to do step by step by step. Okay, so it's going to launch, it's going to click, it's going to enter data into this field, it's going to enter that data into that field, it's going to verify these text boxes have this data. So this is a human readable version of the automated script, okay, if you will. So even as a business analyst, somebody who developed a model, somebody who doesn't know anything about code, I have a vision of exactly what that automation script is going to do step by step. So now here's where the kind of magic comes in. I'm going to generate, just by clicking that button there, and you can't see it because it's way at the bottom of the screen, it right then generated a automation script, okay? And I'm going to now bring up the automation tool I'm using for this demo. We use a tool called Rapise, okay, that is from a company called Inflectra. And this is their tool. They use their tools based on Selenium and JavaScript, so it's very familiar to a lot of people. But this particular tool, so what I'm going to do is right here, right now, this is a view of their structure, and this is the test case I just generated. So let me open that up. This is the actual JavaScript that I just generated. And it shows right here, this was created by IQM Studio on this date at this time. So this I just generated in 1 second into the correct directory structure so that this automation tool can actually see and open that script. Okay. So this JavaScript right here is generated and commented, annotated. You can see the step nodes, all this stuff in here. It's generated by our program, so that you can read this and it tells you exactly what this script is going to do. But the real thing is I can actually run this script right now. My hands are in the air. This script is going to be run by this automation tool. Okay. So you're going to see it start the web page, navigate off to the account screen. Oh, sorry.
Should I put my hands in the air too? I'll put my hands in.
Yeah, you should put your hands in there. I put them in the air too soon because I need to change this. I'm using Selenium. Edge is my browser. I need to tell it that. So now when I click play, it's going to interface with using the web drivers from Selenium by starting up an Edge browser, clicking to the account screen, going ahead, entering the user ID that I specified and the password I specified as valid, and clicking the sign in button and bringing up my account personal information and verifying the data on that screen. Okay, so that automation script just happened. That could have been Selenium or Ranorex or any tool you want. And you can see here, this is the actual logging that Ranorex creates, the step-by-step instructions. And at the end, it tells us all steps passed, right? So it did all those things. So what I just did right there is go from a model to generate a test to automated scripts to a script tool that can run that script for me. And I did all that in 15 minutes, okay? So that there was no coding involved, no test creation. All of that happened by the tool generating those things, okay? So now when you look at results and result logging, that we rely on this tool. This tool has complete result logging and will interface and keep track through its interface, through its automation or its test management tool. We can create code in these scripts that will log errors into Jira or wherever you want them, right? So when these tests run, they can automatically log the results, including bugs and screenshots and anything else you want to put in these scripts, as if you had written these scripts by hand or some engineer wrote them, okay? Okay, so that's really the whole end-to-end kind of a rush job, but we went from a set of requirements to a model, to test generated, to scripts generated, to running those scripts, okay? And that all happened basically orchestrated by IQM Studio, okay? Okay, so Phil, that's the demo.
Well, that was that was fast. Let me go back to this here. All right, can you see my screen now? Let's see.
Yep.
All righty. Okay.
So if anybody has questions, or Phil, if you want to go back, we can look at any detail there that I kind of rushed by.
Sure. Sure. I appreciate the demo. It was great. There's a, it was really fast. So there are a couple pieces that I think are important that you didn't really talk about much. And that is really the tying in with the test management
Yes,
test cases, and then the results coming back from the automation, going back into test management. And you had mentioned Jira, but it also, as you said, works with Azure DevOps as well, which is quite important because a lot of our customers, they're working with Azure DevOps or Jira, right? So both of
Right.
those platforms are really, really important. So it's important to tie that all together. Here's just kind of a summary of today. I hope that those that have attended or watched the video will get this out of it in terms of the importance of great requirements and complete requirements. It's really the start of quality software. Quality software is really not all about coding, but really starting with good requirements for coding, right? So that people know what they're developing. And we work with Bob and IQM Studio as well as Inflextra. So we're happy to work with our clients with these tools to help them to do all this test case generation and automated code generation. And I think we've gotten a great demo and summary, our overview of your tool, Bob. I really appreciate you being here. And
Sure. Well, my pleasure.
yeah,
Thanks for having me. I actually am looking forward, Bill, to us working together, coming up on a lot of different stuff. I think that we're very much have the same value to customers. I really, we've been doing this for a long time, and the industry's been kind of stuck, right? This webinar we just gave, Phil, we could have given 10, 15 years ago, and it really hasn't changed that much. But I'm really optimistic right now that things are starting to change. I think this message of better requirements and bring technology into tracking and managing testing and really getting serious about test automation. I think we're actually, as an industry, starting to mature and start to do that in a serious way.
great. If anybody has questions, please feel to type them into the panel. But this will officially end the webinar. And if you will have questions, you can just write in. There's some contact information on here. There's lots of resources that you can see in those links there in terms of our white papers on agile test automation requirements and so on. So please write in and let us know how you thought about the webinar. The webinar recording will be shared with everyone that attended, as well as those that have registered. And I think that'll be it for today. So thanks very much, Bob. And
Thank you, Phil.
Some more together.
Yes, well, enjoy the rest of your day, and I'm going to enjoy the rest of my evening.
Okay. All right. Thanks, everyone.
All right, thanks all for attending very much. Take
Bye-bye.
care. Bye-bye.